In this demo, I'm going to show you how you can start using Gateway Load Balancer in minutes. We'll do this in 5 steps. The first one being locating a partner's virtual appliance in the AWS Marketplace and deploying it into a VPC wherein all of your appliances live. We're going to simulate a security-based use case. So I'm going to call this particular VPC the security VPC. We'll then create the gateway load balancer in that security VPC along with a target group and register the appliance instances to be targets for the gateway load balancer. For traffic that needs to be inspected from a spoke VPC where application instances reside, we will create the load balancer endpoint in that VPC. And to get traffic to be inspected, we'll update the route table to send all traffic to the gateway load balancer endpoint before it egresses out to the internet. The architecture looks something like this, wherein you have a spoke VPC in which your application instances reside. The EC2 instances need to talk to a resource out to the internet, but we want this traffic to be inspected by a fleet of instances that sit in the security VPC and have that traffic inspected as it comes inbound as well. Now, as the EC2 instance tries to egress out to the internet, we route all traffic to the gateway load balancer endpoint, which sends traffic to the gateway load balancer. The application or appliance instances inspect this, send it back to the gateway load balancer, out to the internet gateway, and follows a similar path back where ingress routing enables traffic to hit the gateway load balancer endpoint before it makes its way back to the application instance. Now let's start figuring out how to deploy this, and we'll consolidate the first 2 steps to locate the partner's virtual appliance in the AWS Marketplace, as well as launch it into that security VPC. So let's head to the AWS console and launch the instance that will act as our appliance. So in this case, I'm going to choose a C5N instance, deploy it into the security VPC. This can be in a private subnet, but if you choose to have a secondary ENI or you want to enable management through a public interface, you can choose to assign a public IP to it as well. I'll now name this particular instance so I can easily identify it. And create a security group that has rules to allow traffic for HTTP, which is TCP port 80. This enables health checks to come in from the gateway load balancer. We allow traffic over UDP port 6081. This is encapsulated traffic we will receive from the gateway load balancer. That's the actual data plane traffic. And I've allowed SSH port 22 in case I want to go ahead and configure this Amazon Linux instance. Great, so now I have an appliance running that's going to simulate or act as the appliance behind the gateway load balancer. Our next step is to go create the gateway load balancer, the target group, and associate it to the appliance instances that we just deployed. So going back to the AWS console, I can go to EC2, click on load balancers and create load balancer. I can then hit the new option that I have in this page, which is the gateway load balancer, and give it a name. The gateway load balancer will live in the same VPC that the appliances that we deployed are in, which is the security VPC. I'll choose to deploy it across 2 availability zones and thereby 2 subnets. And then create the target group that I'll use to associate my appliances to the gateway load balancer. I'll give this a new name. The health checks will be over TCP port 80. And I now have the two instances that I can associate as appliances behind the gateway load balancer. Let's look at our final configuration for the load balancer itself. So we have a gateway load balancer that's going to be in the security VPC, deployed across two subnets, doing health checks over port 80, and we have the two instances that are security appliances that are registered as targets to it. You now created a gateway load balancer along with the target groups, and you've associated it to the appliances as the targets. Now that you created your gateway load balancer, your target group, and registered your appliances as targets for this gateway load balancer, let's now go create the gateway load balancer endpoint in the VPC in which the traffic needs to be inspected as it egresses out to the internet. Let's head back to the AWS console. You now have your gateway load balancer that's available. And to generate the gateway load balancer endpoint, the first step is to create an endpoint service, which is very similar to what you might have done with sort of private link-based deployments. I choose the gateway load balancer. For the purpose of this demo, I'm not going to require acceptance for the endpoints that I'm creating. Hit on create service. And I have a service that I can use to associate my endpoints to. And I'll make sure that I copy the service name over in order to create my endpoints. Go to endpoints and create endpoint and find the service by name. Now that I've found the gateway load balancer service endpoints, I will go ahead and deploy it in the Spoke VPC that I want traffic to be inspected in. I'll deploy it in the public subnet so that when traffic comes back to the gateway load balancer endpoint, it can go out the internet gateway. You now have the gateway load balancer endpoint available to be used in the Spoke VPC. Now that you have the gateway load balancer endpoint ready, let's make the final change, which is to update the route table to send traffic to this newly created gateway load balancer endpoint in the Spoke VPC. Let's head back to the AWS console. I have three route tables in the Spoke VPC. The private subnet route table, which is associated to the application instances. The public subnet route table, which I use to route traffic out to the internet. And then the ingress route table, which is associated to the internet gateway in the Spoke VPC. And I'll use this to route traffic or return traffic rather back to the gateway load balancer endpoint before it makes its way back to the application instance. So let's go ahead and make the first change, which is to default all traffic to the gateway load balancer endpoint. You can do this by pointing to the gateway load balancer endpoint, which is actually a new type of target we've enabled on the subnet route tables. So once you click on gateway load balancer endpoint, you'll see the endpoint ID, which you can choose from. Hit save routes, and you now have egress traffic pointed to the gateway load balancer endpoint. Now, to ensure return traffic is inspected through that fleet of security instances as well, I'll go back to my ingress route table and point the application subnet to route through the gateway load balancer endpoint. Similarly, I just have a drop-down entry for the gateway load balancer endpoint, choose the ID, save routes. As our final step, let's go ahead and verify if I actually have traffic working. Now, as our final step, let's make sure that we have traffic passing from the application instance out to the internet, and to ensure that it's passing through the security appliance. I'm going to do this by first logging on to a Bastion host I have in that particular VPC. Log on to my application instance. Now, just to confirm that, I'll go back to my instances. This is my application instance, and it says 10.0.0.70. I'm logged into the specific instance, and let's see if it works. So you'll see traffic is now flowing through. And to double check if the appliance instance that sits behind the security VPC or the gateway load balancer is receiving this traffic, let's go to the appliance itself. Let's log into the appliance and do a TCP dump on port 6081, which is where all traffic is being routed to from the gateway load balancer. You'll see that I can actually see the ICMP request and reply going through this particular instance. Just to confirm it, the IP address is 192.168.0.75, and the appliance that it's going through is appliance 01, which is 192.168.0.75. So really, we took a few minutes to set this all up, and we hope that you're able to use Gateway Load Balancer to scale your appliance fleets as well. Thank you for taking the time to watch this demo, and we'll see you soon.